All available experts, please report to room A9.
Hi guys, Acto here, and welcome to Egyptian fractions. So, I'm going to phrase this by saying I'm not going to be an expert at this, but I think I've found some sort of method to get this, but the aim of it is we're given a fraction here, and we're trying to recreate that fraction using 1 over a number from 1 to 99. So we'll be using textbook calculator here. So one thing you can notice is this is actually bigger than 1, so our first fraction is going to be 1 over 1 no matter what. So let's make this fraction so we can know what we're aiming for. 867.5 over 7896. Which is equal to this, so that's why we need the 1 at the front. Now, a way I figured out how to get basically a starting block is find out what the factors of the bottom number are. So, factor I don't know what it is down there, but here are the prime factors of it. Not 23, but 2, 2, 2, 2. So now we can just figure out what numbers are possible, because the denominator is a product of all of the denominators, or a multiple of such. So we need to find a multiple. We need to find denominators which are multiple of
Emergency
this.
cleared. All personnel, please return to your stations.
Where the total number of each one is going to be a multiple of this as well, multiplied by a single integer constant. So 47 we can double to get 47 times 2 is 94. That's as big as it'll go. So that's how high the 74 can go. 47. The 7, we can multiply that by the 3. We can multiply by 2. We can multiply by the 3. Yeah. So for 7, we could also have 14, 21. We could have 2 times 2 times 7, which would be 4 times 7, which is 28. We could have 6 times 7, which is 42. We can't do 7 times 7, we can do 8 times 7. We can't do 9. We can't do 10, 11. We can get 12, however, which is 3 times 2 times 2. So 12 to 84. And then we can't get 13, can't get 14. 15, no, 16. Can we get 18? What's 2 times 2 times 2 times 3 is 24. That's the highest one I think we can get to. So does 24 take us over? Yes, so I think these are the probabilities for the 7. And of course we have the multiples we found out, so 2, 3, 4, 6, 7 we can get, but we already noted that down. 4, 6, and 12. 8 is another one of the ones we could get, and 24. So I might have missed a few, but hopefully this is enough to get a starting block. So does a half take us too far? Yes. What about third? Too much. Quarter's too much. 6th, still too much. A 12th is smaller. Is an 8th going to be smaller? No. So we know that we might need 1 over 12 or 1 over 24. Let's start with 1 over 12 for now. And let's go for... Oh yeah, just to mention, there is no denominator less than 1, at least one denominator less than 10, but there is a chance that all of them could be less than 10, because then you have 2 less than 30, 3 less than 60, and all less than 100. So all of them could be small, but I think that's not that often the right answer. Let's go. I feel like 14 will be too much. Yeah. 21? Too much. 28? No. 42? No. 58. Okay, so I'm starting to think that the 12 here is too big. Let's go 1 over 24, and then the 1 over 21. That could also work. And then plus 1 over 98. That's ever so slightly too much. Maybe would this do it? No. Oh no, wait, that's because it's 94, not 98. That's ever so slightly too much now. So this might take a while for me to figure something out. We know we can leave this one as is if we're manipulating these ones. But we know sort of the range we're going for now. Maybe the 47 might help? Let's go for 47 here. Let's go for 24 and 21. No. And 42. Still not quite. You need a bigger number. So let's change this to 28 for now. And then smaller again. So let's get this 58. No, maybe 24. This is going to be me doing a lot of trial and error. Ah, there we go. We now have identical numbers here. Just to check, we can do what isomers do. Put these both in here, and if we highlight them, we get identical numbers. So we found our answer. Put them in order, we have 1, 24, 28, and 47. So we're now going to type this in by adding 10 and 1. If you mess up, you can loop back around to 0. But adding 1 will increment you the first digit up every time as well. So we're first going for 1. Then we're going for 24. Then we're going for 28. So yeah, then we're going for 28. And finally we're going for 47. And if we've done this correctly, you get a module. So hopefully you now understand at least some way of doing Egyptian fractions. And I'll see you guys in the next tutorial. See you later.